All right, Dakota, this is test 24, what we were going over yesterday. This is the correct answer, the one we found on the board. It is the, it clicked, the button was the wrong one. This one was clicked, it should have been this one. It was just like a typo, basically. All right, the next one that you had questions about was this one. So the thing to think about, the thing to remember, is when we solve these line y-intercept, we always are saying y is equal to, right? Y is equal to mx plus b. That is the equation of the line. When we change the equal sign to an equality, it's still talking about y. We still solve for y in order to graph whatever it is we're graphing, right? So y is going to be greater than or equal to. Y is going to be less than. So you have to think about that in terms of we're only considering the y-axis in regards to this inequality symbol. So when we solve and we say y is greater than or equal to, all right, that means that's the green line because it includes the equal to, means it includes the line, so it's a solid line, not a dotted one. So this green line, y is going to be greater than, so we want the values that are going to be bigger on the y-axis than where this splits the y-axis. So all of these values on y are getting smaller when we go this way. They're all getting bigger when we go this way. And because y has to be greater than, we want the bigger than, the greater than, right? Greater means bigger. So we would go above the line for all of the values for this inequality. So that would mean A and D. Now this one would be y is less than. So if y is less than, then, and there's no equal sign, so it's a dotted line. So this is a dotted line, so it does not include the values on the line. It includes the values that are less than y. So if you look where it splits the y-axis, these are getting greater, these are getting smaller, or less than. So it's all of the values on this side of the line. So that would be B and D. And where those two sections, those two line values overlap, you had A and D and you had B and D. So D is the one that is true for both of those. So D would be the appropriate answer. All right, I hope that makes sense. It's all about the y. We don't care what the x-axis is doing. We care about y because we're solving for y, not for x. All right, so let's look at, I think it was, we did that one. It was this one. So this one had a typo. This said 500. It should have said 560, and I've already fixed it. And when that is fixed, the appropriate answer is negative 169 over 35. And I think I solved it over here. Yes, I did. Okay, so when I reduce, all right, we reduce this, we get square root of 4, which is 2 times square root of 5. We reduce this, we get 2 times square root of 5 times 2, so that would be 4 times square root of 5, right? So we've got 5 times square root of 7 and 2 times square root of 5. We want to multiply times 2 times square root of 5 to get rid of this in the bottom, right? So we do that, we get 10 times square root of 35 over 20. We're going to multiply by square root of 7 to get rid of the square root in the denominator. So we end up with 4 times square root of 35 over 7. And then this, when we reduce 560, we get 4 times 35. It's actually 8 times 35 is 560. So we factor out the 8 and get the square root of, we get the, it's 8 times 70. Or 80 times, yeah, it's 8 times 4 times 7. No, it's not. It's 16 times 35. That's what it is. 16 times 35. I did it up here. I don't know why I'm trying to do it in my head. So you had 8, which is 2 and 4, times 7, that's 56. And then 2 times 5, that's 10, right? So you had this 2 and this 2 made a 2. Square root of 4 made a 2. 2 times 2 is 4. Then you had a remainder of square root of 7 and square root of 5. So 4 times square root of 35. This was a 3, so 4 times 3 is 12, square root of 35. All right, we got there. So then, after we did all of that, I reduced this by dividing this by 10 and this by 10. That gives me square root of 35 over 2. So then I need a common denominator, that's 14. So then this would be 7 over 14 minus 8 over 14 minus 168 over 14. This is negative 1 minus 168, which is negative 169 times square root of 13 over 14. So there's that. And I think that's the last one that we could not solve. We did that one. We didn't do that one. You didn't need that one. And I think that was it. That was it. Yeah. All right. So that was it for test 23. Or 24. Let's look at 23. All right. You said number 12. All right, find the distance between these. So I'm going to just take this whole thing over here and drag it in. Okay, so let's get to it. All right, so we have to find the distance. So what we're going to do is we're going to say this is going to be x1, y1, x2, y2. Okay, so 2 minus 6 over negative 6 minus 4. All right, negative 4 over negative 10 equals 4 over 10 when we find the absolute value of those, which is what you do to find the lengths of the legs, right? So this is going to be A, and this is going to be B. So 4 squared, we put it in Pythagoras theorem, plus B squared would be 10, would equal C squared, which is your hypotenuse, right? So 16 plus 100 is equal to C squared. That's 116 square root of is equal to C. So all we have to do is reduce 116 to find the distance between those 2 points. And if we factor that out, you're going to find, all right, you've got 2 times 58. 58 is 2 times 29. All right, so you got 2 and 2, so it's going to be 2 times the square root of 29, which would be this one right here. All right, you also wanted numbers 16, 18, and 19. So let's go to 16. And if these are not the right problems, let me know. This is giving me the numbers. It does say that it's not in random order, so I think these are going to be the same ones that you asked for. But the printout, you know, if the button is checked for randomize, then it will mix them all up, and it's hard to tell. So this is 16. Find the equation of the line that passes through these points. I'm going to go ahead and do the same thing I did before and drag this over into this other right here. Let's scroll this up and then we'll walk through it. All right, so we're going to find the equation of the line that passes through this point and is parallel to 2y minus 5x equals 8. All right, so first we're going to take 2y minus 5x equal to 8. We're going to solve for y. So that's going to be 2y is equal to 5x plus 8 because I added 5x to both sides, so now it's positive. And you want to divide everything by 2 to get y by itself, so it's in the proper format. So we have y is equal to 5 over 2x plus 4 because we can evenly divide that. All right, so now we have our line. And that's this line. The only reason we need to solve that is so we can find the slope. Now we can insert it into a new formula. So y is equal to 5 over 2x plus b. So now we're going to take this point and substitute it in for the x and the y value to find b, which would give us the equation of the entire line, right? You can see where it's y is equal to 5 over 2x. So this is not a possible answer. This is not a possible answer. It's either going to be a negative 11 over 2 or a positive 11 over 2. So that's what you've got to figure out. So let's substitute those points in there. So we've got a negative 2 for y, 5 over 2, and a negative 3 for x. We know we turn a whole number into a fraction like that. So that's going to be negative 2 is equal to negative 15 over 2 plus b. I'm going to add this to both sides because it's negative. Now when I do that, I'm going to turn this into a fraction with the denominator of 2. So it's going to be negative 4 over 2. Negative 4, positive 15, that's going to be a positive 11 over 2 is equal to b. So this would go right back where the b is. So y is equal to 5 over 2x, and it's a positive 11 over 2. So it's going to be this one right here. Okay. All right, you had number 18. What's next? So that would be this one. Scroll that down. So we've got, okay, we got to get rid of this right here. And we'll start with this one. So that would be 1 over 1 times x over x plus p over x. We want to get the same denominator, right? Common denominator. So that's going to be x plus p over x. And that takes the place of this right here. So now we have p over, actually I'm going to write that down here a little bit. This equals x plus p over x. So now our formula, or our expression, sorry, it's not a formula, is p over x plus xp over x plus p over x, right? Because this took the place of this. So now we have a number divided by a fraction. That's going to be keep it, flip it, change it. So xp over 1, and instead of dividing, we're going to multiply and flip this expression. So that's going to be x over x plus p. So then that's going to give me x squared p over x plus p. And that is going to take the place of this. So now I have p over x plus x squared p over x plus p. Well, now we do common denominator between these two. So I'm going to multiply x over 1 times x plus p plus x squared p over x plus p, right? That's going to give us a common denominator. We can add these together. So that's going to equal, let me scooch over just a little bit. X times x is x squared, and then that's going to be plus px plus x squared p all over x plus p, because they have the same denominator now. So that is going to take the place of the entire denominator. So now we have p over x squared plus px plus x squared p over x plus p. So we take this, we we do keep it, flip it, change it again. We have p, we turn that into a fraction, p over 1. We're going to multiply, and we're going to flip this. So x plus p over x squared plus px plus x squared p. So that's going to be x plus p squared. I'm sorry, xp plus p squared. I was about to drop that p. xp plus p squared over x squared plus px plus x squared p. Now we just have to look and see which one matches. All right, so we have px plus p squared. That matches the top. And we need the x to be squared. X squared, px, xp, same thing. All right, so it's going to be this one right here. Okay, so that's how you would solve that. It's always back and forth between common denominator. Then when you get a number over a fraction, keep it, flip it, change it. Then you're back to adding a whole number to a fraction. You do common denominator, make it one fraction. Then you go back to keep it, flip it, change it to combine it with the numerator and make it one fraction, right? Okie dokie. We had one more, and that was 19. Let's go back. This one right here. To make it big enough to see. All right, so 3 plus 4i over negative 2i minus 5. We are going to, first of all, rewrite it because it's in the wrong order. So that's going to be negative 5 minus 2i. We have to put the imaginary number second. Otherwise, it's not going to conjugate correctly. So times negative 5 plus 2i. Negative 5 plus 2i. All right, so I'm going to do the numerator first. Numerator. 3 times negative 5 plus 2i. And then 4i times negative 5 plus 2i. So that's each of the terms in the numerator times this one over here. And that's going to give me negative 15 and a positive 6i. And then that's going to give me a negative 20i. And then 4 times 2 is 8. And then that's a negative 1. So then that would be a negative 8. So I combine all of those together. And I get, because I times I is negative 1, 4 times 2 times negative 1 is negative 8. Right, that's where I got that. So then that would be a negative 23. So right away, we know this is not right. And this is negative, this is negative, this is negative, so we know those are right, okay? And so then I've got a positive 6, negative 20. That's going to give me a negative 14i. All right, so that is my numerator. So I don't even have to solve my denominator because my denominator is 29 in all of them. So I don't even have to do the denominator. I can stop right there and see that it's negative 23, negative 14i. So this is going to be the right answer. But I'm going to go ahead and do the denominator just for the sake of showing you how we get there. Denominator. I can't spell today. So you got negative 5 times negative 5 plus 2i. And then you've got negative 2i times negative 5 plus 2i. All right. So negative times negative is a 25. And then that would be minus 10i. So then you've got negative 2 times a negative 5. It's going to be a positive 5, or a positive 10i, right? Negative 2 times a positive 2. That's a negative 4, but I times I is negative 1. So negative 4 times a negative 1 is a positive 4. So these cancel, and this is 29. So that would be the denominator. Numerator, denominator. And because this has an I, we don't write it in one fraction. We split it because this is an imaginary number. So we don't put it with the real number. We move it over and separate it out. And that's how we would solve for that. So that's a trick for when you're doing the ACT. When you see they all have the same denominator, don't worry about solving for the denominator. Just solve for the numerator and stop. And then you're done and you can go on to the next problem. If all the answers have different denominators and the same numerator, then solve for the denominator. Don't worry about the numerator. But if they're all different, then of course you have to solve all of them. All right, so I think you had, was that the last one? Yeah, that was the last one. If I didn't get the right questions, like based on what was on your paper, because sometimes it prints them in a different order, it shuffles them around, let me know. Like, send me screenshots of the specific problems you need if these were not the right ones. But that's all that you sent me. That's all that we did yesterday. If you have more questions, all you do is let me know, and I'll be more than happy to send you a video. All right, sweetheart, I will see you hopefully sooner than Thursday. But if not, I will see you Thursday. Bye for now.